Hello everyone, my name is Ananya P. Temkar and I am a student from Sri Venkateshwara College of Engineering. In this video, I shall talk about the alternative sources of energy. Don't forget to like the video and subscribe to my channel. Without further ado, let us begin. Energy is the word derived from the Greek word en-ergon, which means in work or work content. Energy is the most basic infrastructure input required for economic growth and development of a country. It is the driving force for humans and machines, and without energy, the world would come to a standstill. Increase in living standards of human beings has accelerated energy consumption. Hence, energy resources should be abundant. Why do we need alternative energy resources? When burning fossil fuels, it can lead to air pollution as it emits poisonous gases such as carbon monoxide and greenhouse gases such as carbon dioxide, etc. Fossil fuels are also non-renewable. Hence, once they are used up, they are not replenishable. Burning of coal in thermal plants has an efficiency of only 30 to 38%. Alternative resources such as hydropower, solar energy, and wind power are more environmentally friendly. Also, some energy sources such as nuclear energy is more efficient. In this video, I shall talk about the following alternative energy resources. They are hydropower, solar energy, wind power, and nuclear power. Let us begin with hydropower. Hydropower is generated by hydroelectric power plant. The energy of water is utilized to drive the turbine, which in turn runs the generator to produce electricity. Rain falling upon the Earth's surface has potential energy relative to ocean towards which it flows. The energy is converted to shaft work. The hydraulic power is thus a naturally available renewable energy. Now let us look at the working of a hydroelectric power plant. First, the process begins with the intake of water from a river or reservoir. The water is collected at a high elevation to harness the gravitational potential energy. The water is then directed through a large pipe or conduit called a penstock. The penstock is designed to control the flow of water and guide it towards the turbines. As the high pressure water flows through the penstock, it strikes the blade of a turbine and it captures the kinetic energy of the moving water. The rotating turbines is connected to a generator. The generator consists of a rotor and a stator. As the turbine turns the rotor, it induces a magnetic field in the stator, creating an electric current. A transformer. As the generated electric current is usually in the form of alternating current. This alternating current is then sent through a transformer, which increases the voltage of the electricity. Transmission lines. The high voltage electricity is transmitted through power lines to a substation. At the substation, the voltage is adjusted again before the electricity is sent to the power grid. The electricity is finally distributed to homes, businesses, and industries through the power grid. Now let us talk about solar energy. Solar energy is the energy derived from the sunlight. It is generated by solar panels on a large scale. Let us look at the working of a solar power plant. A solar power plant consists of the following important components: solar panels, inverter, transformer, power grid connection, and net metering. Let us talk about solar panels. They consist of many photovoltaic cells made of semiconductor materials, usually silicon. These cells can convert sunlight into Direct current electricity. When sunlight hits the solar panels, the photovoltaic cells absorbs photons. This absorption generates an electric current within the cells due to the photovoltaic effect. The direct current electricity produced by the solar panels is then sent to an inverter. The inverter's primary function is to convert the direct current into alternating current, which is the standard form of electricity used in most homes and businesses. The alternating current is then sent through a transformer, which adjusts the voltage to the appropriate level for transmission and distribution. The electricity generated by the solar power plant is fed into the power grid. It can either be used on site or distributed to a broader electrical grid to meet the energy needs of homes and businesses. In some cases, solar power plants may be connected to the grid using a net metering system. The net metering system allows any excess electricity generated during sunny periods to be fed back into the grid, and the owner of the solar power plant receives a compensation for the surplus energy. Now let us talk about wind power. Wind power is generated by a wind power plant. It uses the kinetic energy of wind to generate electricity. Let us look at the working of a wind power plant. A windmill has the following components: blades, rotor and hub, generator, transformer, transmission lines, and grid connection. The wind turbines are strategically placed at locations where the wind speed is relatively high and consistent. As the wind blows, it causes the turbine blades to rotate. The aerodynamic design of the blades allows them to capture the maximum amount of wind energy. Rotor and hub. The rotating blades are connected to a certain hub. The hub is mounted on a shaft, and as the blades turn, they cause the hub shaft to rotate. The rotating blades are connected to a generator. This generator converts the mechanical energy from the rotating shaft into electrical energy. Inside the generator, the rotating blades turn the rotor within a magnetic field, inducing an electric current in the generator's coils. The transformer adjusts the voltage of the electricity generated. In some cases, power conditioning systems may be used to ensure that the electricity produced by the wind turbine meets the required specifications for connections to the electrical grid. Transmission lines. The electricity is transmitted from the wind turbine through cables and transmission lines to a substation. At the substation, the electricity is integrated into the larger electrical grid. It can then be distributed to homes, businesses, and industries. Now let us talk about nuclear energy. The energy released by fusion or fission of nuclei of atoms is called nuclear energy. A nuclear reactor is a device which controls the nuclear fission chain reaction to harness the nuclear energy. The nuclear reactor is used to generate electricity, and it is called a nuclear power plant. Nuclear energy is 8,000 times more efficient than traditional energy resources. However, it is not a renewable energy resource and produces radioactive waste. Let us talk about the working of a nuclear power plant. A nuclear power plant has the following components: nuclear fuel, control rods, heat exchanger, turbine and generator, cooling system or a condenser. In a nuclear power plant, nuclear fuel is in the form of pellets and are enclosed in several tubular claddings of steel or aluminium. This is called the fuel assembly. Enriched U-235 or Pu-239 is used as fuel material. The fast neutrons released during fission are slowed down by a moderator, usually graphite surrounding the fuel assembly. A coolant is circulated through the reactor to remove the heat generated. Ordinary water is most commonly used as coolant. Other coolants such as heavy water, liquid sodium, molten salts, and hydrocarbon liquids are also used. Rods made of boron or cadmium, which are neutron absorbers, are used as control rods. The neutrons available for fission are controlled by moving and the control rods in and out of the nuclear core. The heat produced during fission process is absorbed by the coolant and is used to convert water into steam in the heat exchanger. The steam is used to rotate the turbine, which is connected to a generator which generates electricity. The entire reactor is enclosed in a concrete building to prevent radioactive radiations being released into the environment. I hope you found this video informative and learned something new. Don't forget to like and subscribe and share this video with your friends and family. Thank you for watching and have a nice day.